The first thing you want to do when you walk in the lab is turn the computer on. Go to your station, turn the computer on. The reason you have to do it right away is because it takes a long time to log in. And then once it's in, just give it some time, wait for it, but you can pull this thing out. It's pretty cool. So I'm pulling this out, move your mouse around, and then you'll see what goes on here. So I'm just going to hit the space bar. Now I'm going to say OK. Now in here you have to put your username. So your username is your student number. So I'm going to type in my username, so Dulak. And your password. Hit enter, and then just sit, go for a coffee. No, but don't. It takes a while, but just be patient. Actually, at this time, you can go get your components. Okay, so when you get in, it looks like this, and then just log into Blackboard from there. Now over here, you're going to do the same thing. You're going to put your student number and then your password. Now once you're in here, you're in Blackboard, so now go into the course. Go into the labs. If you're in lab section A or section B, whichever one, go into the right section and then go into the lab and then just start the lab up. Okay, so here we go. We're in the lab. Now you've already got these components, so let's continue on. Let's begin, and then we're going to go through the process. We're going to take a look at the lab, and we're going to do these things, take these measurements, and continue forward with all of this. We're going to do the first step for lab 1, where we're going to measure the value of the resistance for these resistors. I'm going to go over and turn my DMM on. Just turn the power on, let it boot up. It'll take a second. Now what I want to do is I want to measure resistance. So I'm going to go over and I'm going to press that button over there. So now I'm on resistance. Now I'm going to measure the resistors here. So as far as the measuring goes, I could put this probe in here or this in here, but it kind of flops around a little bit. So I'm actually going to take this and I'm going to stick it right in there, and I'm going to stick that right in there, and look what the meter says. There you go. So that's 99.76 ohms. So write that down. Now when we go over here, we're going to see something different on the meter. Now that is 0.200, but kilo ohms. What it is really, it's 200.79 or 78 ohms. So write that down. I want you to write the value in ohms. Down here, we're going to go to this guy. We're going to continue. So that is the 400 ohm resistor, and it's reading 398.87 ohms. Write it down. We're going to go over to the 800 ohm resistor. Again, it'll show you 799.34 ohms. So we can see that whatever this is labeled, it's pretty close to what it's labeled, but not exactly. Now, the second part to this is actually flipping the polarity. So remember that number, 799.34. I'm going to do this. I'm going to flip it. Oh, 79.34. So resistors, doesn't matter which way you measure them, they still read the same thing, or they're not polarity sensitive. We're going to check continuity. It checks for continuousness. So what I'm going to do is I'm going to turn my DMM to check for continuousness or continuity, and then we'll actually go through a practical application where we look at a switch. So let's check out the DMM. So looking at my DMM, I'm going to hit this guy over here, and that shows a little beep, and that's continuity. So now always the first thing you do when you're checking continuity is do this. Hear that beeping? I always check to see if it's working. Now, what I want to do is I want to check the polarity of this, or more specifically the polarity of which one this is flipped. So I want to have this so that when I flip it up, the switch is closed, and when I flip it down, the switch is open. So what I'm going to do now is I'm going to say, well, I'm just going to test this. I'm going to put this guy in here and this guy in here, and oh, look at that. I'm hearing that thing beep. That means it's closed. I want it to be closed when it's up. So I'm actually going to flip it up and just check to see if it's not broken. There's no continuity when it's up. So when I put this into my circuit, I'm actually going to put it in this way, because when it's up, it's more intuitive. Here we go. Now, when I flip it up, it'll beep. There you go. That tells me that there's a continuous connection through this switch. So let's take a look at the variable DC power supply. I'm going to turn it on. I'm going to show you how to choose a channel and set the voltage. I'm going to turn it on. Now, both of these channels are off. Just to let you know, that's 5 volts all the time. And the button for that is over here. You can turn it on or off. These guys have a variable voltage to them. So that's channel 1, channel 2. So channel 1 is off right now. I'm going to turn it on. When I turn it on, you can see the voltage here. And then it probably is at 24 volts, but let's actually just adjust it up to 24 volts. So you just adjust it until it's at 24. It doesn't have to be exactly 24, but if you want to get it right on 24, that's better. There you go. So now what I can do is I can turn this channel off. So there's no power coming out of here, but it's still set to 24. Now I can just turn it back on again. I can do the same with this and this. So that's it for voltage for now. We'll talk about this a little later. Let's hook up this voltage section here, question 4. So what I'm going to do is I'm just going to build this circuit. That's my power supply. It's right there. That's my single pole, single throw switch, and these are my 2 resistors, and there are my motor. So I have all of these components, and I am now going to place them. I'm going to place my components in order that I see them in my diagram. So in this case, the first thing I see is my switch. So I'm going to put my switch in here, and I need you guys to put your components in these little holes here. The next thing is this resistor set. So these resistors are all like this, so that's fine. I mean, they're beside each other in the diagram, but that's fine. So I'm going to put it like this. By the way, some of the resistors are 800, 400, 200, 100, and some are like this. So just read them. And then the next thing in my circuit is my motor. You know what? I'm going to put my motor kind of like this because that's how it's kind of seen in the circuit. Now I'm going to continue to hook up my circuit. The first thing I see here is I see power coming out here and going into one pole of my switch. So I'm just going to take this power here, but before that I'm going to turn this off. Now I'm going to go into one pole of my switch. From there I see another wire coming out of my switch going into the left side of a 100 ohm resistor. So I'm going to go into the left side of a 100 ohm resistor. Out of the right side of my 100 ohm resistor, I'm going into the left side of a 200 ohm resistor. So I'm going to plug that in there. Now out of the right side of the 100 ohm resistor, I'm going to go into the top of the motor. Okay, good. So from the bottom of the motor, see the circuit? From the bottom of the motor, I'm going to go back to my power source, but that's the negative. So I'm going to use a black wire. So let's hook that up. So from here, I'm going to go into the negative of my power supply. Now I've got my circuit. I make sure that my switch is connected in a manner so that when I flick it up, it's going to be closed. And if you can see, I don't know if you remembered from when we did the continuity, that should be on the bottom. So I'm going to undo this, and it's okay for me to undo my circuit because the power's not on. And I'm going to flip that over so that when this is down, it's open. Here we go. So now my circuit's hooked up. I'm going to turn the power on just by hitting this one output. I've got 24 volts here. Let's see what happens. When I flick this switch, this motor should come on. Sweet, it's on. Now let's take some voltage measurements. To take voltage measurements, I need to turn my DMM to DC voltage. So I'm going to go over and hit DC voltage, and you can see that button in your lab. It's that one right there. Now I'm going to put my probes. They actually have polarity. So depending on which way I'm going to put them, I know that I'm looking at the voltage drop across this, and there's a higher voltage here than there is here. So I'm going to put my positive here and my negative there. Again, I can do this or I can put them in there. Now, write that down. So that's 3.09 volts. So I'm going to write that down. Now I'm just going to click down here and take my next reading. So now I want to measure the voltage drop across resistor 2. I'm going to put that probe in there and that probe in there and look at your DMM. It's a higher voltage. Write it down. Write down 6.26 volts. Now what I want to do is I want to find the voltage drop across my motor. So I can just put this in here and that in there, but I want to make sure that I put the polarity properly. That's going to have a higher voltage than this one. That one's actually connected right over to here. It's connected to here. So that is actually negative or 0 voltage. So I'm going to put this guy over here, my black there, and I'm going to put this here, and we'll see what the voltage drop across the motor is. There we go. It's 14.60 volts. Write it down. So my motor is running at 14 volts. But that's because these resistors are stealing some of the voltage. I mean, I'm starting with 24. So why is it only getting 14? Because I'm losing voltage across here. You know what? I'm going to take one of these right out of the picture. I'm going to actually bypass it or short it. So I'm going to put this wire here. I'm just going to take a wire and I'm going to put that in there and I'm going to put this in here. Now, when I put this in here, watch the motor and listen. It's going faster. I don't know if you can hear that or not, but it is, and you'll see. So I have taken out that 100 ohm resistor, so that voltage drop doesn't exist across this. Now, I'm going to do the same over here, and I'm going to take both of them out. I'm actually going to go from here, and I'm going to bypass both of them by putting this right here. Now, listen to the motor again. That's pretty fast. So this guy is now dealing with the voltage directly from here. Let's take a measurement. If I measure the voltage drop across this motor, because I don't have any voltage drop across any of my resistors, I'm getting 23.975 volts. So essentially, that's 24 volts, and that's the original reading that we got when we checked to see what the voltage coming out of here was. So what we did there was we had actually kind of two different speeds we had for that motor. If I wanted to, I could replace these leads with switches. Let's actually put a switch in here. Again, I'm going to put my switch so that that dot is down, so I know that that's open and that's closed. I'm going to put this guy in here, and now I'm going to take this wire here and I'm going to put this over here to the 200 ohm resistor. It's closed, so I'm going to open it again. Now listen to the motor. When I close this switch, I'm shorting this and the motor will speed up. So what's going on is that I've now got control with a switch. So you've got to figure out how many different settings I can put in here if I add another switch. For step 5, or question 5 in this lab, what we're going to do is we're going to be studying the current that's traveling through here using the DMM, but we're also going to be calculating the two resistances of this. One is more, we're going to study the static resistance of this and then calculate the dynamic resistance, and we'll see that they're different. So first thing I'm going to do is I'm going to shut my circuit off. I'm going to turn this off. It's always good practice to do that. What I want to do is I want to measure the resistance of my motor. So I make sure that I'm on resistance. I'm going to do this guy over here, and when I check the resistance of my motor, you can see that it's 91 ohms. Okay, so the resistance of this motor is 91 ohms, but that's when it's not working. What happens to its resistance when it's working? Does it change? Well, we're going to discover that. We're going to actually calculate the resistance using Ohm's law. But for now, I'm going to put my circuit back together. And then I'm going to measure current. But to measure current, I have to change the configuration of this. These two probes are measuring voltage, but to measure current, I have to actually do something different. I'm going to remove these. I'm going to take these right out of the picture, and I'm actually going to use the banana plug wires that we have in the lab. So here, I'm going to put this into the ground, or the black or the negative. So I'm just going to go straight in there, and now I'm going to put this guy into a different spot. I'm going to put him down here. And that's the port we use to measure current. These ports are for voltage, that port is for current. So now I've got these two wires coming out of here that are just replacing these. Wires are wires, it doesn't matter what they look like. Now, I want to hook this circuit up. As you can see, my meter is stuck inside there. I've got to physically break the wire or break the circuit and force the current through the meter, and that's what we're going to do. What I want to do is I want to capture the current that's traveling through this wire. Imagine the current as you're hooking things up. The current goes from here into there. I want to break that and make it go through the meter. Well, I can actually break it by just doing this. putting that over there, and I know that the current wants to come out of here and go there, so I'm gonna make it go into the meter first. I'm just plugging that in there. Now it's going into the meter, it's gonna come out of the meter, and it's gonna go here. So, but that's not it yet. I have to set this thing to measure current. So let's do that. The way we do that is we're gonna measure DC current. So I'm gonna hit shift and then this. And now that's on DC current. Okay, so let's turn this power on. Make sure your switch is off. Turn your power on. And as I flick the switch, we're gonna watch the current go up. Okay, so that's 31 point. So we'll let that settle a little bit. The actual motor changes its properties as it goes. And we saw that there was a spike at first, and now it's kind of evening off. So you can write down for yours the last two decimal places. I need you to actually enter some values. So just enter, in this case, 30. I would enter 30.50 or 30.51 or something. But I need you to put some decimals in there. I need you to put some values in there. So we know the current, but in this case it's milliamps. And you can see that because you can see the little M, it's milliamps. And it's okay, when you write the numbers in your lab, it knows that it's milliamps. At this point, we're gonna consider the resistance of this motor. Before, when we measured that resistance, it was around 90 ohms. But if we actually calculate the resistance here using Ohm's law, we can actually see that the dynamic resistance actually changes. It's different than 91 ohms. Now what we're going to do is we're going to kick up the current. The way we're going to do that is we're going to take out or short one of the resistors, and we're going to watch the current go up. So I've already got my current, it's stable. I mean, it's great to have these banana plugs because I don't have to use these probes every time I want to measure something. It's already measuring something. What I'm going to do is I'm going to bypass this resistor, and we know that when I did that before we had more voltage here. When I bypassed both of them, we had a lot of voltage here. So in this case, when we have more voltage, we'll have more current as well. So I'm going to bypass this and watch the current go up. Just a little bit, just a little bit. I'm going to bypass both of them, and you'll see the current go up even more. So it went to 37, 36. So this thing, as we know, when we bypass these, my motor is getting 24 volts. As I take this off, it goes back to 14, and as I do this guy, it's a different value, and as I do this guy, it's a different value, again, controlling the speeds, but in each case, we see that there's different current as well. We're gonna watch the resistance or the resistive nature of the dynamic resistance of the motor change as I put a load on it. So a load is like whatever it's moving. If this was moving in conveyor belt and you put something heavy on the conveyor belt, it would be a heavy load, or it would increase the load for the motor. I'm gonna simulate that just by squeezing it with my finger. Now, as I put my finger in here, I'm going to squeeze it a bit. Watch the current. Watch what happens. Oh, it goes up. Why does the current go up? Well, because the resistance is changing. As I put a load on this, the resistance is changing. It's pretty cool. You think about if the resistance is getting higher or lower.